Hello everyone, welcome back to Science Free. Our topic today is exponents in math. And today we will be covering all the exponent rules, as well as solving a few exponent questions, so that you will get a clear understanding and master this topic. Exponents are just expressions used to represent repeated multiplication. So on your screen, there are 3 being multiplied by itself 3 times. So we just place the base and use 3 to represent the exponent, because it was being multiplied by itself 3 times. Similarly, we have the letter x being multiplied by itself 3 times. So we just place 3 for the exponent and leave x for the base. Here is an example of exponent and base labeling. Whenever we have 2 numbers or letters that have the same base and are being raised to an exponent and also are being multiplied together, we just need to add the powers. This is called the power rule for exponents. Similarly, we have 2 letters that are being raised to different powers or exponents, which are x, and are being multiplied together. We need to add the exponents and keep the base. 10 plus 3 equals 13. So we left with x raised to the power of 13. For this example, we have 3 times x in bracket raised to the power of 6 times another x in a bracket that is also being raised to the power of 6. We can place like terms together. Both of the x's are the only like terms. Okay, so now we have 3 in bracket being multiplied by 2 x's that are in a bracket with the same exponent that is also being multiplied by each other. So let us solve the x terms in bracket first. We want to add the powers and keep the base. 6 plus 6 equals 12. So we are left with 3 times x raised to the power of 12. As you can see, for this example, we have 2 different letters that have the same term in pair and are raised to some exponents. Let's first place these terms in groups. On the left-hand side, we have y raised to the power of 8 times y raised to the power of 7. And on the right-hand side, we have z raised to the power of 5 times z raised to the power of 7. On the left-hand side we now add the 2 exponents which are 7 and 8. And on the right-hand side, we add the 2 exponents of the z which are 5 and 7. On the left-hand side, after adding the exponents of both y, we get y raised to the power of 15. And on the right-hand side, after adding the exponents of both z, we get z raised to the power of 12. So we get y raised to the power of 15 times z raised to the power of 12. Using the product rule, let's solve this expression. We need to group like terms. So far we have 3 x terms in the numerator that are being raised to some power. And also in the denominator, we have 3 y's raised to some different powers. Let's now add the powers for x. That's x raised to the power of 3 plus 2 plus 4. For the denominator we have y raised to the power of 2 plus 3 plus 4. Adding the powers for x we get 9. And adding the powers for y, we also get 9. So we ended up with x raised to the power of 9 over the denominator, y raised to the power of 9. For this expression, we have x raised to the power of 2 in the bracket, but outside the bracket there is another exponent of 4 that everything in the bracket is also being raised to. For this expression, we just have to multiply both powers, and the result we get that will be the new exponent that it will be raised to. So multiplying the exponents we do 2 times 4, which equals 8. So we get x raised to the power of 8. And this is called the power rule 2 for exponents. What about this one? We have x times y in the bracket, but outside there is an exponent of 3, which means everything in the bracket is being raised to the power of 3. So removing the bracket, we then have x raised to the power of 3, and also y raised to the power of 3. This is called exponent rule 3 for products. The product is just two or more numbers or letters in a bracket multiplying by each other and is being raised to an exponent outside the bracket. Whenever we have either numbers or letters in a bracket being divided into each other and is being raised to an exponent outside the bracket, both the numerator and denominator are raised to that power. This is called the power rule 3 for quotients. Remember, any number or letter that is being raised to a power, that is the number of times that number is being multiplied by itself. Both the numerator and denominator is being raised to the power of 2. Here we have an example where we need to apply power rule 2 for exponents to solve. Right here outside the bracket, there is a negative sign. That negative sign is just an invisible -1 outside the bracket, which is being multiplied by everything inside the bracket. Working out the bracket to the right first, we could times -2 by itself 2 times. Because in the bracket it is being raised to the power of 2. Negative times negative would give positive, so we are left with a positive 4. Let's raise this positive 4 to the 4 outside the bracket. That is 4 being multiplied by itself 4 times. We got 256. We could have also times the powers to arrive at this answer, which is 256. That's how the power rule 2 for powers work. So now we are left with a -1 that is being multiplied by 256. Any negative number that is being multiplied by a positive number, the answer will become negative. Or any positive number that is being multiplied by a negative number, we'd still get a negative answer. -1 times 256 equals -256. Here in the bracket, we have 5 and 4 being multiplied by each other and are raised to the power of 2 outside the bracket. Five raised to the power of 2 equals 25. And 4 raised to the power of 2 equals 16. (16 times 25 equals 400). We could have multiplied the 5 and 4 in the bracket, which would give 20, and then we raised the answer to the power of 2 outside the bracket. And we'd get 400 for the answer. This next example requires us to use the power rule for quotients, which we covered earlier. Both the numerator and the denominator in the bracket are being raised to the power of 4 outside the bracket. 2 raised to the power of 4 equals 16. And 4 raised to the power of 4 equals 256. So we have 4 over 256. For this example, we have x raised to the power of 4 divided into y raised to the power of 2. And both variables are raised to the power of 3 outside the bracket. To solve, what do you think we need to do? Well, we need to multiply the powers of x and y by the power that they are being raised to outside the bracket. For x raised to the power of 4 and outside the bracket raised to the power of 3, we multiply the powers and that will give us x raised to the power of 12. Similarly, we do the same for y. Multiplying the powers, we get y raised to the power of 6. For this example, we have a negative exponent which is -4, and we want to change it into a positive exponent. To do that we have to focus on the quotient. We have to interchange the numerator and denominator. Notice we now have x for the numerator now and 2 for the denominator. We now place back the bracket and raise the quotient to a positive 4 as the exponent. Working out the numerator for this quotient, we get x raised to the power of 4. Raising the denominator 2 to the power of 4, we get 16. For this example, we have 5 in bracket raised to the power of -3. And also raised to the power of 1 outside the bracket. Multiplying the power 1 by the other exponent, which is the -3, we get back -3. Any number that is being multiplied by 1 will give back its original value. For this exponent, which is the -3, to become positive, we have to place 1 over the base. And then raise the quotient to a positive 3 as the exponent. The numerator 1 raised to the power of 3 equals 1. 5 raised to the power of 3 equals 125. We have 2 raised to the power of -3, and we want to change the exponent into a positive 1. We place 1 over the base and raise both numerator and denominator to the power of 3. One raised to the power of 3 gives 1. 3 raised to the power of 3 gives 8. We get 1 over 8. For this example, we have 7 raised to the power of -3 inside a bracket and are being raised to the power of -1 outside the bracket. We can work out the bracket first. 7 raised to the power of 2 equals 49. So we now have 49 raised to the power of -1. For the exponent to become positive, we place 1 over the base and place back the exponent as a positive 1. Any number that is raised to the power of 1 will give back the same value. Any base with a positive number and is being raised to the power of 0, we get 1. If the base was negative, we get a -1. What if we had a quotient where both numerator and denominator are being raised to powers that are negative? How do you think we would solve this? Well, we have to interchange the numerator and denominator. So we would have 9 for the numerator with its exponent being positive, and 2 for the denominator with a positive exponent. For this example, we have x raised to the power of 3 divided into y raised to an exponent of -7. We want to make the exponent for y positive. We cannot interchange because the numerator already has a positive exponent. The denominator doesn't have a positive exponent, so we bring it up beside the numerator for it to become positive. And the answer now becomes x raised to the power of 3 times y raised to the power of 7. The final rule which we are now covering is called the quotient rule for integer exponents. This rule applies to quotients with the same base. In this rule, we minus the exponent of the numerator from the denominator exponent. We have 4 raised to the power of 7, which means 4 times itself 7 times. For the denominator, we have 4 raised to the power of 3, which means 4 is being multiplied by itself 3 times. We now need to cancel, starting from the top to the bottom. Now we are only left with 4 multiplying by itself 4 times. That's 4 raised to the power of 4. Noticed in this example, the exponent for the numerator has a smaller value than that of the denominator. This means we will get a fraction after finish cancelling. One is multiplied by itself any amount of time is just 1. And the denominator 4 is being multiplied by itself 2 times. So we get 1 over 4 raised to the power of 2. In this example, we have x raised to the power of 7 divided into x raised to the power of negative 2. We just need to minus the exponent 7 from the exponent negative 2. Subtracting exponent 7 from exponent negative 2, we get 9 as the answer. We get 9 because 2 negative sign gives positive. For the answer, we are left with x raised to the power of 9. For this example, we have x raised to the power of 3 times 7 raised to the power of 8. And is being divided into x raised to the power of 6 times 7 raised to the power of 6. Because we have to write the answer with positive exponents, we start with the base 7 at the top because its exponent is larger than that of the base 7 in the denominator. We then minus 6 from 8, we get 2. Similarly, for the base x in the denominator, we start there because the x in the denominator exponent has a larger value than the x in the numerator. We are left with 7 raised to the power of 2 over x raised to the power of 3. Thank you for watching. Please remember to like, subscribe and hit that notification bell if you haven't, so you won't miss out on any of our science and math tutorials. Our next topic will be on transposition.